Assalamualaikum and hi madam. Today our group would like to present our application called Number System Studio. Number System Studio is an all-in-one desktop application that combines a scientific calculator and a number system converter into a single interface. Instead of using different applications, users can perform calculations and convert number systems in one place. This application is mainly designed for students, programmers, and engineers who frequently work with mathematical calculations and different number systems. The calculator supports basic arithmetic operations, trigonometric functions such as sine, cosine, and tangent, as well as memory functions for easier calculations. Besides that, the converter can instantly convert decimal numbers into binary and hexadecimal in real time, making the application faster and more convenient to use. Overall, Number System Studio provides a simple, user-friendly, and efficient interface that helps improve productivity by combining both tools into one application.
Now let's move to calculator interface. I'm showcasing our dual interface Java Swing calculator, which bridges robust arithmetic with real-time basic operation. As highlighted inside, the project focuses on a refined controller and GUI layout, setting a solid foundation for cross-based data handling. Deep diving into the technical insight, the calculator uses a state-based engine with first number, operator, and start new number flag to ensure accurate sequential operations. We have also implemented a scientific and memory suite alongside a synchronized multi-text field architecture for seamless decimal, hex, and binary data binding. To maintain system stability, we utilize document listener hooks and its updating converter flag, which serve as a semaphore to prevent infinite recursion during live synchronization. The entire interface is built on a responsive border layout and 4x6 grid layout, constrained to a fixed 800x360 window. By prioritizing this concurrency, safeguard, and clean statement management, we have built a highly reliable and performant tool.
For trigonometric calculation subsystem, it provides built-in sine, cos, and tangents function that allows user to calculate trigonometric value based on the entered angle. The subsystem processes the input instantly and display accurate result for scientific calculation.
Next, I will explain the number system converter feature. This feature allows users to convert decimal numbers into hexadecimal and binary instantly. The converter consists of 3 labels, 3 text fields, and 1 clear button. Users only need to enter a decimal value, while the hexadecimal and binary fields are automatically updated and set as read-only. We also implemented real-time conversion and error handling using try-catch to prevent invalid inputs. The clear button resets all fields. For example, if the user enters 15, the application displays F in hexadecimal and 1111 in binary. The real-time conversion is implemented using a document listener which updates the output whenever the user types in the decimal field.
Next, let's look at the core functional requirements and features of our system. The application implements a stateful memory management subsystem. This is a fully operational calculator memory retention system utilizing standard key commands MC, MR, MS, and M+. This subsystem allows the application to store, recall, clear, or accumulate floating point values seamlessly in the background, ensuring data is preserved accurately even during complex multi-step computation. Moving on to our main output, we will now walk you through the core functionalities of our system calculator features. As you can see on the screen, the interface is split into a classic calculator layout on the left and a real-time number system converter on the right. Let's start with the fundamental operations. First, we are demonstrating the addition operation. When a user keys in an addition problem, the calculator processes the sum in the main display, while simultaneously translating the final value into its decimal, hexadecimal, and binary equivalent on the side panel. Next, we have the subtraction operation. Just like the previous features, the system handles standard arithmetic smoothly. Once the subtraction is executed, the backend logic instantly updated the conversion fields, ensuring that the binary and hexadecimal strings dynamically match the new arithmetic result. On our next slide, we demonstrate the division operation. These features allow users to perform quotients and division tasks. The system calculates the quotient instantly, ensuring accuracy before passing the final calculated value over to the number system conversion panel. Following division, we have the multiplication operation. The calculator effectively processes factors and computes products. This slide highlights how the system reliably manages larger numeric values resulting from multiplication, updating the binary bits and hexadecimal characters accordingly without any lag. Beyond basic arithmetic, our system calculator also supports advanced algebraic functions. Here we are demonstrating the square root function, which is triggered using the specialized button on the layout. The application instantly computes the root of the input value and updates the base conversions on the right in real time. Finally, we have the trigonometric button feature. This allows users to compute geometric and trigonometric ratios directly within the application. When a trigonometry function is called, the calculator evaluates the expressions and displays the outcome, showcasing the versatility of our system's core features.
Now let's move to calculator interface. I'm showcasing our dual interface Java Swing calculator, which bridges robust arithmetic with real-time base operation. As highlighted inside, the project focuses on a refined controller and GUI layout, setting a solid foundation for cross-based data handling. Deep diving into the technical insight, the calculator uses a state-based engine with first number, operator and start new number flag to ensure accurate sequential operations. We have also implemented a scientific and memory suite alongside a synchronized multi-text field architecture for seamless decimal, hex and binary data binding. To maintain system stability, we utilize document listener hooks and its updating converter flag, which serve as a semaphore to prevent infinite recursion during live synchronization. The entire interface is built on a responsive border layout and 4x6 grid layout, constrained to a fixed 800x360 window. By prioritizing this concurrency, safeguard, and clean statement management, we have built a highly reliable and performant tool.
Next, I will explain the number system converter feature. This feature allows users to convert decimal numbers into hexadecimal and binary instantly. The converter consists of 3 labels, 3 text fields, and 1 clear button. Users only need to enter a decimal value, while the hexadecimal and binary fields are automatically updated and set as read-only. We also implemented real-time conversion and error handling using try-catch to prevent invalid inputs. The clear button resets all fields. For example, if the user enters 15, the application displays F in hexadecimal and 1111 in binary. The real-time conversion is implemented using a document listener which updates the output whenever the user types in the decimal field.
For addition, we take 98 plus 6, giving a sum of 104. Simultaneously, the backend logic converts this base 10 value across 3 computing formats: decimal, hexadecimal, and binary. Next, for subtraction, we subtract 35 from 105, leaving 70. For division, 50 divided by 25 yields a quotient of 2. Moving to multiplication, multiplying 25 by 25 computes a product of 625, showing how smoothly the system updates larger values. We also support algebraic functions. The square root of 4 yields a precise answer of 2. Finally, our trigonometry feature calculates geometry ratios instantly. When we input sine 90, cosine 360, or tangent 225, the system evaluates the expression and display output perfectly.
Next, this is the compute method. This method is responsible for performing the arithmetic calculation based on the operator selected by the user. It receives the 3 parameters, and 1 is the first number, and 2 is the second number. OP is the mathematical operators such as addition, subtraction, multiplication, or division. Inside this method, we use a switch statement to check which operator is selected. If the operator is add, it returns the sum of the two numbers. If it minus, it returns the difference. If it is star, it returns the multiplication result. If it is divide, it first check whether the second number is 0 to avoid division by 0. If this divisor is 0, it returns 0. Otherwise, it performs the division. Finally, the calculator value is returned to the calculator and displayed on the screen. After that, we have the update converter method. This method automatically updates the number system converter whenever the calculator produces a result. First, the variable is updating converter is set to true. This prevents the document listener from running repeatedly and creating an infinite loop while the text fields are being updated. Since the converter only works with whole number, the calculator result is converted from double to integer. Then, the decimal value is displayed in the decimal text field. The hexadecimal value is generated using integer.2hex string, and the binary values is generated using integer.2binary string. Finally, its updating converter is set back to false, allowing the converter to respond normally to future user input. Lastly, this is the main method, which is the starting point of the program. We use swing utilities invoke later to ensure that all swing components are created and executed safely on the event dispatch thread. Inside this method, we create a new object of the number system studio and call set visible true so that the application window appears when the program starts.
In our project, we apply these 5 fundamental swing GUI components play essential roles in building a responsive and organized calculator interface. The JFrame serves as the primary top-level container, providing the necessary window frame that encapsulates the entire application and allows it to interact with the underlying operation system. Within this frame, JPanel's objects function as lightweight, modular containers that are crucial for grouping and managing layout of various buttons and text fields, ensuring the UI remains structured. The JButton component acts as an interactive bridge between the user and the logic, enabling specific events to trigger calculation or state change whenever a user interacts with the buttons. Furthermore, the JText field provides the essential area for real-time data input and output, allowing the calculator to display decimal, hexadecimal, and binary values clearly. Finally, the J-label serves as a vital display-only component, used to prevent static text or label throughout the interface, which significantly enhances user navigation and clarifies the function of specific calculator sections.
Delegation for Izati, she responsible for developing the complete calculator application. She designed the GUI layout, implemented the arithmetic engine for mathematical and scientific operation, and set up the multi-text field architecture for real-time number system conversion. For Zahra, she was responsible for explaining the number system converter. She covered the decimal, binary, and hexadecimal conversion features, demonstrate the real-time conversion and input validation. And Aimi, she responsible for explaining the calculator spec and logic. They presented how the programs handles user input, performs trigonometric and mathematical function, and manage the scientific memory operation. And for me, Humaira was responsible for the mathematical function and system integration. She explained the arithmetic operation, division by zero validation, automatic decimal, binary and hexadecimal conversion updates, the application startup process and conclude